Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi, everybody. Tonight I'll be doing the review for test 3. And let me just remind you, let's go to D2L. And if you look at the announcement on D2L, this Thursday, the 10th, I'll be giving test number 3 online on Thursday by 8 a.m. or earlier. I will send out the password for test 3 PDF file, which will be in the assignment area of Blackboard. You'll download it and you have until Friday, 8 p.m. to finish test number 3 and upload your answers to the assignment area D2L. This is important as a single PDF file. It should take you about 40 minutes to finish the actual test, assuming you've studied. I hope you have. But please take as much time as long as you get it uploaded by the deadline on Friday, 8 p.m. Now, test 3 has 9 pages. Oops, itchy eye there. And 10 problems. Some of the problems have multiple parts. I have never given a multiple choice question in Chem 170. It will cover the functional groups, carboxylic acids, esters, carboxylate anions, amines, amine salts, quaternary ammonium salts, near and dear to my heart, amides, and heterocyclic compounds. And here we have general knowledge points breakdown, 7 points, nomenclature, 38, and reaction, 60. It adds up to 105, so there's five bonus points. Now, this won't be an open notes test or open internet, you should do this on your own. And I'm having my review right now. And by Sunday at the latest afternoon, I will have the scores posted in D2L for test number 3. And I will also have emailed out to each of you the individual email with the points for each answer you receive on test 3. All right, before we go through the review, let me go to student view. All right, let's go to content. And then here I'm in the lecture folders of D2L. Now, if you scroll all the way down, you'll see this button at the bottom that says load more. You'll need to click on that, and I am, with your left mouse key. Now you can see more files. Don't ask me why. D2L is a very old software. And if you notice, here's review 3 as a Word document you can download, or review test number 3 review as a PDF file. Again, you'll have to click on the load more button to see this. All right. Before I start the review, how do you do well on test 3? First of all, remember there's always 4 bonds to carbon. I gotta get this finger fixed. 4 bonds to carbon. Ooh, same thing happens on this side. 4 bonds to carbon. Also, when you look at a molecule, look for what's different. What's not a carbon-carbon single bond or carbon or hydrogen atom should get your attention like that, because that's where all the fun is in the action. Yep. All right. The other thing, how do you do good on test number three, one. Hopefully you've watched all the videos for the material on test three. Next, you've done the practice problems for the functional groups. And finally, you memorized the general reactions for the functional groups on test number three. And those general reactions are in test number three review. So what I'm going to go through is material that you should know. All right, let's get started. First functional group is a carboxylic acid, carbonyl, carbon double bond oxygen with a hydroxyl group, that's OH, and an R group on the carbonyl carbon. How do you name it? Find the longest chain with the carbonyl carbon, carbon double bond oxygen. Name it as an alkane. Drop the E. Add the letters OIC and the word acid. Remember, the carbonyl carbon is always number one. So if you have substituents, you'll number that carbon as one. Now, there are a couple of common names and one name actually that's both common and IUPAC. But first of all, the simplest, when R is a methyl group, it's not really the simplest, but when R is a methyl group, this carboxylic acid, nobody calls it ethanoic acid. It's known by the common name acetic acid. And when you take 4% acetic acid, approximately, this little tilde means approximately, and approximately 96% water, and you mix them together, you know what you get? Yes, vinegar. Vinegar is essentially water, a very dilute solution of acetic acid. Now, the next I talked about when R is a hydrogen, and that's formic acid. And that's the acid that the fire ants mix with water, heat up, and use as a defensive weapon. Now, finally, when R is a benzene ring, don't forget to put the lines inside when you draw a benzene ring, you have benzoic acid. This is the common name, and IUPAC, like I've done other times, few times, something that's been around for many eons. They don't change the name and made benzoic acid also the IUPAC name. Now, a carboxylic acid is an acid. Acid is a proton donor, H plus. What is the acidic proton in a carboxylic acid? The hydrogen on the oxygen of the hydroxyl group. And if you react it with a base, where for this class, we'll use a simple hydroxide base where M is lithium, sodium, or potassium, you get a proton transfer, and the organic molecule you get is this, which is called a carboxylate anion or salt. I like the carboxylate anion. Now, I show my charges O minus M plus. You don't have to, but I do. I think it looks cool. Did I ever tell you Dr. White is always trying to be a cool dude? All right, now, there's one special base I would like you to know about, and that's sodium bicarbonate, which is found in baking powder. And this is where I would ask you, give all the products, and give means draw. So you have a carboxylic acid, and this is a base. You get the carboxylate anion. Here, the cation is sodium plus. You get what's called carbonic acid, which immediately breaks down to water and carbon dioxide, CO2, which is a gas. That's what this arrow pointing up shows. And if you remember, and I got a big smile because I'm remembering something very nice from my childhood. My father showed me in these little plastic rockets, if you put some vinegar, or ours methyl acetic acid, and baking powder, close it up and wait, the CO2 form builds up a pressure and it pops it off. When you're 5 or 6 years old, that is really spectacular. All right. Now, how else can you make a carboxylic acid? If you take a primary alcohol right here, a primary alcohol, and O in brackets means oxidize. I'm not asking you to learn oxidizing reagents like potassium permanganate, sodium dichromate, or potassium dichromate, and there are others too. Just O in brackets, oxidize, and this becomes a carbon-carbon carboxylic acid. Now, one thing I neglected to mention earlier, oh, excuse me, is another important thing for test 3 is, do you break carbon-carbon single bonds? No. Let me do that full screen, slow motion. Do you break carbon-carbon single bonds? No. So don't. Make sure there are always 4 bonds to carbon. I'm going to get that finger fixed one of these days. All right, now you can also oxidize an aldehyde. And I used this reaction, the one before, when I was doing my PhD thesis to make carboxylic acids I needed. And here you oxidize an aldehyde, carbonyl with an R group and H, to a carboxylic acid. And finally, one that I like, why? Because you know Dr. White loves Grignard reagents, is if you take a Grignard reagent, R, MgX, where X can be chlorine, bromine, or iodine, and react it with carbon dioxide, CO2, second step, H plus means acid, H2O, I hope you all know is water, you get a carboxylic acid that's 1 carbon longer than the R group it comes from. And that carbon here comes from the CO2. And you make a carboxylic acid. Now, a derivative of a carboxylic acid, something derived or made from a carboxylic acid, is an ester. Carbonyl with an R group, with an oxygen. And on the oxygen is R prime. Remember, R and R prime are like X and Y in math. They can be the same or different. Here, R means, or R prime, something with carbon and hydrogens in it. And this is an ester. Now, just to remind you, esters are responsible for the smell of flowers and the taste and smell of fruits. And also vegetables. Next time you smell a flower like a rose, you're smelling esters. Next time you smell or taste a banana, you're tasting and smelling an ester. Same thing with some other of the fruits, not all, but some of the others, and some of the vegetables. Now, an ester, how do you name it? Now, you name the R prime as the alkyl group in front. Now, the IUPAC way is name the carboxylic acid if R prime were hydrogen used to make that ester. Then drop the IC in the word acid and add ATE. Now, I had a very sharp Chem 170 student years ago said, except for when R is a benzene ring, you can also name it R prime is still the alkyl group in front. And then find the longest chain with the carbonyl carbon, R and carbonyl carbon, name it as an alkane, drop the E, and add OATE. And let me just do one example. And I would ask, give the IUPAC name for the following. And you say, well, I have an ester, carbonyl. Again, look for what's different, what's not carbon, what's not hydrogen, and an oxygen to the carbonyl with an R group here, R prime, and an R group here. Oops, don't want prime there. And that's an ester. Now, since R is not a benzene ring, we can do 1, 2, 3. So that's propane, but the R prime goes in front, and that's a methyl group. I almost wrote CH3. And then propane, drop the E and add OATE. And that's methylpropanoate. Now, when R is a benzene ring, then you have to use the IUPAC method. R prime, ethyl. This part, if it were carboxylic acid, is benzoic, and there'd be an IC in the word acid, which you drop and add ATE, and that would be ethyl benzoate. So when R is not a benzene ring, you can use that student's method. Now, a common ester, common name, nobody calls this ester ethyl ethanoate. No, it's ethyl acetate, comes from acetic acid. Drop the IC in the word acid and put in ATE, and that's how you get the acetate. And this is one of the two molecules that is a nail polish remover. Now, another functional group you should know are carboxylate anions, which we showed earlier. And for this class, I'll just go through where M, the cation, M plus, can be lithium, sodium, or potassium. Now, how do you name those? You name the cation as the element it comes from in front. And then name the carboxylic acid either used to make that ester, in this case, carboxylate anion, drop the IC, add the word and the acid, and add ATE. If R is not a benzene ring, find the longest chain with the carbonyl carbon, the 2A and 2B, or not 2B, that's what I always do that, sorry. But anyways, B2 and A2 are the same as for esters and carboxylate anions. The only difference in is carboxylate anion, you name M plus as the element it comes in from. And as I mentioned earlier, esters are responsible for the smell of most flowers and the taste the smell of many fruits and vegetables. Now, how do you make an ester? You do the esterification. I forgot his name right now. Fischer esterification, and that's named after the great German chemist Emil Fischer. And he is also known, you'll learn later in the semester about his work with sugars that help figure out the structure of many sugars in our daily life. All right, carboxylic acid, alcohol, H plus acid catalyst, and you make an ester. The carbon in R prime with the hydroxyl group is the carbon in R prime here bonds this oxygen. I'll say that again. The carbon in R prime with the hydroxyl group is the carbon in R prime in the ester this oxygen right here is bonded to. Now, once you have an ester, what can you do with it? Well, the first thing is acid hydrolysis of an ester, this reaction right here. And this is an important reaction because you will learn later on, I already know, this is the reaction your stomach uses to break down all fats and oils you consume. Because don't forget, in your stomach, you have H plus, hydrochloric acid. I always think of that one of the miracles of life, that we have cells in our stomach that make acid. Well, here you have an ester reacted with acid, H plus, and water, H2O, and you get back the carboxylic acid plus the alcohol you would have used to make that ester. And the carbon in R prime with the oxygen, the ester, is the carbon in R prime of the alcohol with the OH group. Now, you can also treat an ester with base. And here we'll use lithium hydroxide, where M is Li, Na sodium hydroxide, or K potassium hydroxide. Now here, because you're in base, the carboxylic acid you get immediately becomes the carboxylate anion. In all of chemistry, there's no faster reaction than an acid-base reaction. So you will never find a carboxylic acid present in this reaction. You will have the carboxylate anion, but you do get the alcohol that you would have used to make that ester. So once again, ester, base, and water, you get the carboxylate anion of the carboxylic acid you would have used to make that ester, plus the alcohol you would have used to make that ester. Again, the carbon in R prime with the oxygen is the carbon in R prime with the OH group in this alcohol. Now, one that's near and dear to my heart, because it's a Grignard reagent again, and that is actually two of them. You take an ester, react it with 2 molecules of a Grignard reagent, and I don't have it here, but remember, X can be chlorine, bromine, or iodine. And you make not one, but 2 carbon-carbon single bonds from the Grignard, and you make 2 alcohols. And here, keep your eye on the carbonyl carbon, that carbon, which becomes this carbon. It still has R attached to it. This part leaves to become this alcohol. And usually make R prime small, and this allows you to make very complex molecules simply, very. Oh, by the way, I will never put a synthesis problem. There'll be 3 or 4 synthesis problems on test 3. With this reaction, I will never put a synthesis problem. That's not fair. All right, next, another area I worked heavily in, and that's amines and amine derivatives. But first, water break. All right, now amines are nitrogen compounds. And unlike carbon, which only has 4 bonds, nitrogen can have 3 or 4 bonds to it. Nitrogen can have 3 or 4 bonds to it. And in amines, you have a primary amine, 1 R group on the nitrogen, and 2 hydrogens, 3 bonds. Amines all have 3 bonds to nitrogen. Here you can have a secondary, and I'll never ask on a test what's primary, secondary, or tertiary. And you can have 3 R groups, and they can all be different. So actually, this should be R double prime, R prime, and R double prime can be the same or different. Now, nobody uses IUPAC for amines if you work in industry, which I have for many years. So we used a common name. Name each R group as the alkyl group in front and add the word amine at the end. Now there's one very special amine, and like phenol, IUPAC said, well, we'll use the common name. And that's aniline, where R is the benzene ring and you have NH2. Now, something really near and dear to my heart, let me smile and remember good memories, I just did, is a quaternary ammonium salt. And that's where you have 4 bonds to nitrogen, R prime, double prime, triple prime, and it has a plus charge because it's giving up both of its non-bonding electrons to bond. And all molecules in nature, all molecules have a net 0 charge. So if this has a plus charge, you need the anion, counter anion, with a minus. And for this class, we'll stick to the halogens. X can be chlorine, bromine, or iodine. And this is an area Dr. White is a world authority on. I have a number of patents, US patents and foreign patents. Now, everybody used a common name. Name each R group as the alkyl group that's in the front. Then to add the words ammonium halide. Now, when we say halide, if X is bromine, that would be bromide. If X is chloride, Cl minus, that would be chloride. And if X is I minus, it's iodine. Now there's a mistake here. Oops. Now it's fixed. Now amine salts, amines are bases accepting protons, so you can form an amine salt. And note here for amine salts, in a quaternary ammonium salt, all the R groups have carbons. In an amine salt, R has to have carbons, but R prime and R double prime can be hydrogen, one or both. And good news, you name amine salts the same way as quaternary ammonium salts. Name the R groups in front, and then the anion is bromide, chloride, or iodide. Now, how do you make an amine? Well, if you take an alkyl halide, RX, and react it with ammonia, NH3, in the presence of base, you'll get a primary amine. Remember, X can be chlorine, bromine, or iodine. Now that's how you make a primary amine. The nitrogen here is bonded to carbon that had the halogen. Now, if you take a primary amine and react it with an alkyl halide and base, you make a secondary amine. If you take a secondary amine, react it with an alkyl halide, you'll make a tertiary amine. Now, one really neat way, and this is the first reaction I actually did research on when I joined a company working in the chemical industry long ago, AxoChem. If you take a nitrile, that's a carbon nitrogen triple bond. And just like a carbon-carbon triple bond, carbon nitrogen triple bond has 2 pi bonds and 1 sigma. And pi bonds you can break like that. You don't break carbon's nitrogen single bonds that easily. And if you take hydrogen excess, the letter bracket X and S, close bracket, means you have all the hydrogen in the world, anything that can react with hydrogen will. And a catalyst, abbreviated CAT, the catalyst can be nickel, platinum, or palladium. You break the 2 pi bonds, and each atom of the triple bond, carbon, nitrogen, gets 2 hydrogens, which you can write this way or this way. Now, not one last, but another reaction of an amine is where you take a tertiary amine that means R prime, and R double prime all have carbons, and react it with an alkyl halide, the presence of base, you make a quaternary ammonium salt. And this reaction in the company I work for, and my responsibility in all of North America, and also helped out other places in the world, helped pay for my mortgage, a couple of cars, and a whole lot of other things. So that's why I'm smiling. This reaction really paid off for Dr. White. No, I didn't invent it, but I knew how to improve it. Now, one thing I should mention, quaternary ammonium salts are excellent fabric softeners and antimicrobial compounds. In the company I sold for, we made the molecule when I was there and accounted for about 60% of the molecule that was used in Downy fabric softener and Snuggle fabric softener. And also one of my patents, one quaternary ammonium salt, was used as an antimicrobial compound in operating rooms. Yes. Now, amines are bases. If you take a primary, secondary, tertiary amine, where R prime and R double prime can be hydrogen, and react it with an acid HX, where X is chlorine, bromine, or iodine, you'll have a proton transfer and you'll form an amine salt. Don't forget the anion, because all molecules have a net zero charge. Now, an important derivative of amines are amides. And amides have a carbonyl, carbon double bond to oxygen, with an R group. On the carbonyl carbon is the nitrogen. Then you have R prime and R double prime on the nitrogen attached to the carbonyl and an amide. Now, R prime and R double prime, one, both, or none, can be hydrogen. And again, here, nitrogen has 3 bonds. In amines and amides, 3. In quaternary ammonium salts, and in amine salts, it's 4 bonds to carbon, the nitrogen, sorry. How do you make an amide? Carboxylic acid plus either ammonia or primary, secondary amine. Remember, R prime and R double prime can be hydrogen. When they are, that's ammonia, NH3, or if they're carbons, it can be a primary, secondary amine, and you make an amide. You will learn later on, Mother Nature uses this reaction. That's how, and I'll be teaching you later near the end of the semester, bringing together amino acids forms proteins. I think you've all heard of the term peptide bond. And the peptide bond between amino acids is really an amide bond, and I'll teach you that later on. Now, once you have an amide, what can you do? Well, we'll come back to this one, and that's acid hydrolysis of an amide. And if you take an acid and why HCl instead of H plus? Because that's the acid in your stomach. And you will get back the carboxylic acid you used to make that amide. But the amine you get is a base in the presence of acid. The fastest reaction is acid-base reaction, and you'll form the amine salt of the amine you would have used to make that amide. And we'll learn later in the semester, actually you will, I already know it, that Mother Nature in your stomach uses this reaction to break down protein that you consume to amino acids. It's amazing. You're a walking chemical plant, really organic chemical plant, mainly. All right, remember R prime and R double prime, one, both, or none can be hydrogen. Now, you can also take an amide and react it with base and water. And for this class, I'll just stick to sodium hydroxide, NaOH. Now, instead of getting the carboxylic acid you would have used to make that amide, in the presence of base, carboxylic acid makes the carboxylate anion. Excuse me. So you'll get the carboxylate anion of the carboxylic acid you would have used to make that amide, plus the amine, because amine is the base, NaOH is the base, they don't react, no reaction. Next, I talked about heterocyclic compounds. And the thing, first of all, you should know, and you should know how to define what is a heterocyclic compound. And that's a ring with carbon atoms and other atoms such as oxygen and nitrogen. And the one example I'd like you to know, which is both the common and IUPAC name, is pyridine. And that looks like a benzene ring, six-membered ring, but one of the carbons has been replaced with a nitrogen. And that's it. Now, once again, remember, hopefully you've watched the videos, do the practice problems. And the review I just went through, which is located in the lecture section of D2L, don't forget, you got to use your mouse. Let's see, got to use your mouse to, I've got a fancy mouse that's colored. I can change the colors. I actually have another computer with a different color mouse. But anyways, don't forget, you'll have to click on the Load More button and look at test number 3 review. Those are the reactions you will need to know for test 3. And with that, I'm done. Don't forget, this Thursday at 8 a.m. or earlier, I will be sending out the password for test number 3. Remember, in my class, there's no such thing as a dumb question. If you have any questions, email me. Thursday morning, I won't be home, but I'll be busy. But Thursday afternoon and most of Friday, I'll be available if you have any questions. And with that, I'll say gehen gesund. That's Yiddish for going out. And you know what's coming next. Yep. Bye now. Bye. Stole that from Granny and the Beverly Hillbillies. Bye.